Hello friends, welcome to the solution video of mock test 25. In this video we are going to discuss 30 questions. Moving on to first question, what they are given is consider the signal x of t. So they are telling x of t is power signal, energy signal, neither energy signal nor power signal, both energy signal as well as power signal. Now what is the definition of power signal? A power signal is a one whose amplitude should be equals to a finite value. Whose amplitude should be equals to a finite value at plus or minus infinity. At plus or minus infinity, its amplitude should be a finite value. Now what do you mean by energy signal? An energy signal is a one whose amplitude equals to 0 at plus or minus infinity. So no any signal can be power signal as well as energy signal. So option 4 will be wrong option. Now look at over here, at t equals to plus or minus infinity, what we are getting is amplitude equals to 0. Well and good. But at t equals to 0, what is the amplitude? Amplitude is tending towards infinity. So the signal is neither power signal nor energy signal. So the corresponding option that's going to follow is option 3 is correct. If at all, if at any point of time, if you are getting an amplitude equals to infinite, then it is neither energy signal nor power signal. Moving on to the next question, what they have given is IPv6 protocol is of dash bit addressable. We know that IPv6 protocol is of 128-bit addressable. If they are asking with respect to IPv4, IPv4 is of 32-bit addressable. So this one you have to remember. So the corresponding option that is going to follow is option 4 is correct. Third question, synchronization of bits is taken care by which layer of open system interconnection? So it is taken care by session layer. It is taken care by session layer. So option is option 4. Wattmeter is always going to read real power, average power, reactive power, none of the above. We know that in the case of 2 wattmeter method, the wattmeter is going to read average power. The wattmeter is going to read average power. Now you should know what is the basic difference between a real power, average power and reactive power. Owen's bridge quality of the coil is low. If I am talking about Maxwell's bridge, the quality of the coil is medium. If I am talking about Hayes bridge quality is high. If I am talking about Anderson bridge, then also the quality coil is low. So Owen's bridge as well as Anderson bridge, quality of the coil will be low. So the suitable option that's going to follow is option 2 is correct. Thermocouple is an example of first order system. Number of inductors and capacitors you are going to use, that determines the storage element and that determines the order of the system. So it is first order. Higher order XNOR gates can be implemented using lower order XNOR gates. It is wrong. If I want assertion to be right, what is the adjustment I have to make is higher order XOR gate can be implemented using lower order XOR gates. XOR gates is possible, but XNOR gates is not possible. So assertion is wrong. What about the reason? Complement of XNOR gate is XOR. It is correct. So assertion is false, reason is true. Option 4 is correct. Open loop system is more stable when compared to closed loop system. Yes, because in the case of closed loop system, we can make use of negative feedback and positive feedback, and the system may become stable or the system may not become stable. Right? What is the reason they are specifying is open loop system response is very much faster when compared to closed loop system. Yes, because in the case of open loop system, output depends only on the present input, but in the case of closed loop, output not only depends on input, it depends on the feedback value also. So assertion is talking about stability, but reason is talking about response. So reason is not specifying the proper explanation for assertion. So I have to opt for option 2. If the poles are at minus 10, minus 2, calculate rise time. Most of the persons, how they will be solving is, they will be writing k divided by the poles are at s plus 2, nothing but it is at minus 2, right? How we are going to represent is s plus 2 into s plus 10. Now they are going to convert into our standard expression, that is s square plus 12s plus 20. right? They're going to multiply 20 and 20 over here. right? So what you will be getting is this one they are going to compare with respect to this k divided by 20. I am going to call it as k dash into omega n square divided by s square plus 2 zeta omega n s plus omega n square. Now what is the value of omega n? Omega n equals to root 20. What is zeta omega n? Zeta omega n equals to 6. Because 2 zeta omega n equals to 12, I will be getting zeta omega n equals to 6. So what is the value of zeta? It is 6 divided by omega n, that is 6 divided by root 20. Now how we are going to calculate the rise time? Rise time, how you are going to calculate means you are going to make use of the formula, that is pi minus cos inverse of zeta divided by omega d. What do you mean by omega d? Means you are going to make use of this expression. Omega d equals to omega n into square root of 1 minus zeta square. So thinking it is a second order system, you are going to solve like this and you are going to substitute and you will be getting the rise time value. But none of the option is correct. Now the system what they are given is k divided by s plus 2 into s plus 10. Now you think about dominant pole and insignificant pole. This s plus 2 will be a dominant pole. S plus 10 will be an insignificant pole. Right? So directly we can't neglect this s plus 10. So what you have to do is you have to maintain that gain and then we can neglect, right? Or else you can remove it. So what I will be getting is k divided by 10 into s plus 2 into 1 plus s divided by 10. Now I can neglect this term. The pole I can neglect. So what I will be getting is k divided by 10 into, let me take 2 also as common. What I will be getting is 0.5 times of s plus 1. Right? So this k divided by 20 is your gain value. Now you have to compare this one with respect to k dash divided by s tau plus 1. K dash is the overall gain, tau is time constant. Time constant value I am getting it is 0.5. Time constant I am getting 0.5. Now how can I calculate rise time? Rise time how can I calculate? It is 2.2 times of tau. What I am getting? 2.2 times of 0.5. Nothing but 1 by 2 I am getting. So which is equals to 1.1. None of the option is going to follow. None of the option is going to follow. So whenever they are talking about insignificant pole, try not to consider it as second order system or third order system. Try to remove that insignificant pole and get the answer. So I am getting the rise time equals to 1.1 seconds. So whenever rise time equals to 1.1 seconds, none of the option is getting matched. So it is none of the above. Identify the universal gates among the following. NAND gates and NOR gates only they are telling. So it is wrong. MUX is a universal gate, NAND gates, NOR gate is a universal gate, XOR is not a universal gate. Right? So option B is also wrong. When A and B is wrong, 3 is also wrong. Right? Nothing but C is also wrong. XOR and XNOR gate is not a universal gate. So the only option that's going to follow is option 5 is correct. Right? So which and all are universal gates? NAND gate is a universal gate. NOR gate is a universal gate. MUX is a universal gate. Encoders is a universal gate. Decoders is a universal gate. ACE gate is a universal gate. Apart from this, even demultiplexer is also a universal gate. If you have not watched the video how demultiplexer is a universal gate, I am going to put up a link in the description, or else you can click on I button. Negative feedback in a closed loop system does not reduce the overall gain. It does not reduce the overall gain. It improves disturbance rejection, yes. Reduces bandwidth, yes. Reduces sensitivity to parameter variation, yes. Now if I am making use of closed loop system, overall gain reduces. Disturbance it will reduce. Bandwidth it will increase. Sensitivity with respect to inputs will be more. With respect to environmental disturbance, it will be less. So this is in the case of negative feedback. So all these parameters you should know. Now if I am talking about trigonometric Fourier series of an even function will not be having this sine term. Now in general, if I am talking about trigonometric Fourier series, it will be having cosine term as well as sine term. DC is an exception. Area of even signal. Area of even signal, if I am considering it as a periodic signal, it will be like this. It will be like this. Nothing but it will be having a finite area. It will be having a finite area. And if I am talking about an periodic signal, say suppose you just consider white noise also. This white noise also is symmetric with respect to first quadrant as well as second quadrant. So it is an even signal. So in this even signal, area is how much? Infinite. But here it is finite value. But here it is finite value. Now if I am talking about only like impulse kind of thing, if I am considering only impulse kind of thing, at t equals to 0, the value is present. T not equals to 0, value is not going to present. T not equals to 0, value is not going to present. So can I tell the signal is not lying in first quadrant as well as not lying in the second quadrant also. So area under even signal is always finite or infinite, right? Area under even signal is finite or infinite. 0 doesn't make any sense, right? So you can't say. It can be finite or it can be even infinite also. So 0 actually I should not have given this option. Poles and zeros are arranged alternatively on negative real axis. Then the type of a network is, it is RC network or RL network. So the pseudo option that's going to follow is option 4 is correct. Freewheeling diode is used to protect load, power supply, SCR, all of the above. Freewheeling diodes are used to provide a protection for the SCR. So what you will be having is, you will be having a switch will be like an SCR, and you will be having a load over here, and you will be having a load over here. Here you are going to apply the power supply, and the freewheeling diode you are going to connect over here. So whenever the switch is on, nothing but SCR starts conducting. At that time entire voltage will try to appear across this load. Now what is the purpose of this freewheeling diode is, it is acting like a reverse bias, no problem. But as soon as when you switch off the power supply, as soon as when you switch off this VS source, what is the thing that's going to happen is, this load voltage will try to replicate over here. Across the switch it will be there. So such a huge voltage which will be damaging your SCR. So what you are going to do is, you are going to provide a discharge path. You are going to provide a discharge path over here only. Over here only. So switch is protected. Nothing but SCR is protected. So the corresponding option that's going to follow is option 3 is correct. In a series RLC circuit given R equals to 10 ohm, L equals to 3 millihenry, C equals to 0.3 microfarad. Calculate the bandwidth they have given. So bandwidth we have to find. And what they have given is quality factor which is equals to 5. Quality factor they have given it as 5. So how we are going to calculate quality factor, which is 1 divided by R into root of L by C. And what is the formula for bandwidth? Bandwidth equals to FR divided by Q, where FR is the resonant frequency. How we are going to calculate FR? FR is given by 1 divided by 2 pi root LC, which is equals to 1 divided by 2 pi into root. What is the value of L? L value is 3 milli. And what is the value of C? C value is 0.3 micro. 0.3 micro. So if I am taking common, I will be getting 2 pi. I will be taking 3 also as common. If I am taking 3 as common, this will be 0.1 will be there. That 0.1 if I am sending over here only, it will be 10 power minus 10. The 10 power minus 10 if I am sending outside, that will be 10 power minus 5. So I came to know what is the value of FR. Just substitute over in this expression. So what I will be getting is bandwidth equals to 1.06 kilohertz. Nothing but option 1 is correct. Now in the case of multi-tone modulation, if the signal having modulation index as 50%, 60% and 70%, what is the equivalent modulation index they are asking? So the total modulation index, which is given by mu1 square plus mu2 square plus mu3 square, which is equals to, what is the value of mu1? Nothing but modulation index 0.5 square plus 0.6 square plus 0.7 square. So what you will be getting is 0.5 square will be how much? 0.25 plus 0.36 plus 0.49. Now what I will be getting is under root of 0.25 plus 0.36 plus 0.49, I will be getting under root of 1.1, which is equals to 1.04. So the corresponding option that's going to follow is option 1 is correct. Arrange the bands in an increasing order of the frequencies. So first we'll be having L band, S band, C band, X band. Then afterwards it will be Q, K, and then it will be Ka. So what is the frequency range? Anyway, you'll be knowing it is 1 to 2 gigahertz. Like that you're going to solve. So in an increasing order of the frequency. So if you are knowing the frequency, lambda can be calculated. Lambda equals to C by F, and then you're going to solve. So the corresponding option that's going to follow is option 1 is correct. Scaling factor of resistor. A resistor is given by V divided by I. So V is scaled by 1 divided by beta, and I is nothing but mu and Cox W by L into VGS minus VTH the whole square. What is Cox? That is epsilon ox by Tox. Tox you are going to scale by 1 divided by beta. VGS minus VTH square you are going to scale by beta square. So again you will be left with only 1 divided by beta and 1 divided by beta. So the scaling factor of a resistor will be equals to 1. Nothing but resistance can't be scaled. So the suitable option that's going to follow is option 3 is correct. In order to realize 4096 multiplexer, how many 2:1 multiplexers are required? Straight away you can tell it is 4095. Say suppose if you want to realize 8:1 multiplexer, how many multiplexers you are in need? So you are having 4 multiplexers. So you are having 4 2:1 multiplexers, again 2 over here, again 1 over here. So put together 7 you have used. So with the help of the same logic, if I am going, I will be using 4095 2:1 multiplexers. So the corresponding option that is going to follow is option 2 is correct. If the conduction current equals to 10 amperes and the displacement current equals to 0.9 amperes, what they are telling is the medium is. We know that in order to judge which type of medium it is, we have to calculate for loss tangent. Loss tangent is given by tan phi, which is equals to ratio of conduction current to displacement current, or sigma divided by omega epsilon, where sigma is conductivity and omega is 2 pi f, epsilon is epsilon naught times of epsilon r. So what you will be getting is JC equals to 10 divided by 0.9. So what you will be getting is which will be greater than 10 only. So if it is greater than 10, then you can classify it as a conductor. Right? So what I got is the medium is a conductor. If JC by JD, if I am taking, if it is less than 10, then it is dielectric. Or you are going to call it as an insulator. Less than 10 means actually it is less than 0.1. Right? So less than 0.1 if I am taking, it is dielectric or insulator. Anything which is lying between 0.1 to 10, what I am going to tell is it is a quasi-conductor. Or a semiconductor. So option 1 is correct. Arrange the band gap of the materials in a particular order. Now if I am talking about germanium, it is 0.67 to 0.72. Now if I am talking about silicon carbide, it is roughly 2.2 or 2.3 you will be getting. Now if I am talking about aluminum nitrate, I will be getting 6 electron volts. If I am talking about carbon, it is a 5 electron volts or 5.1 electron volts. So if I am arranging in a particular order, what I am getting is germanium, silicon carbide, carbon as well as aluminum nitrate. So the suitable option that is going to follow is option 3 is correct. Moving on to the next question, what they have given is an electromagnetic wave in a non-magnetic medium having E equals to E naught cos of omega t minus beta y times of x. Right? The intrinsic impedance equals to, they are asking. Now what is the value of omega? Omega we got 3 into 10 power 8. And beta value you got 1. What is the phase velocity? Phase velocity is given by omega divided by beta, which is equals to 3 into 10 power 8 divided by 1, which is equals to 3 into 10 power 8 meter per second. Can I tell it is same as speed of light, which is same as speed of light. If it is same as speed of light, then you will be getting mu r equals to 1, which is equals to epsilon r. So what I will be getting is intrinsic impedance eta, which is equals to under root of mu divided by epsilon, which is equals to under root of mu naught times of mu r whole divided by epsilon naught times of epsilon r. So I'll be getting eta, which is equals to under root of mu naught divided by epsilon naught into under root of mu r divided by epsilon r. What is the value of mu naught divided by epsilon naught, which is equals to 120 pi, and mu r and epsilon r, what is the value? I am taking it as 1. So the value what you will be getting is 120 pi or 377. So the suitable option that is going to follow is option 2 is correct. Next question, we have to find the relation between phase velocity as well as group velocity. Phase velocity and group velocity. Now, if I am talking about the phase velocity will be taking the least value of speed of light and maximum value it can catch infinite. Similarly, if I am talking about group velocity, minimum value is 0, maximum value it can catch speed of light. So, can I tell phase velocity is always greater than or equals to group velocity? But strictly speaking, we are not bothered about phase velocity. Always group velocity is the one which is going to carry the information. The signal which is going to carry the information, that is referred as group velocity kind of thing, right? So the suitable option that is going to follow is option 2 is correct. Next question, for a given open loop transfer function, they have given gh of s, which is equals to k into s plus 2 into s plus 4 whole divided by s square they have given. What they are asking is find out the valid breakpoint. So let us go for pole 0 plot. What I am getting is I am having 2 poles at the origin. 1 0 is at minus 2, one more 0 is at minus 4. So I have to calculate the valid breakpoint. Now keep a point over here, right side how many poles and zeros are there? 2. So it is inverse root locus, or root locus will not exist. But here 3 points are there. So here root locus will exist. Now if I want to calculate the breakpoint, how I am going to calculate is dk divided by ds. I am going to calculate and then I am going to equate it to 0. So that is d by ds of k into s plus 2 into s plus 4 whole divided by s square I will be getting. Now what you have to do is k you replace at 1 and then you have to solve. So what I will be getting is d by ds of s square plus 6s plus 8 whole divided by s square, which is equals to 0. Make use of u by v rule. What I will be getting is s square into 2s plus 6 minus s square plus 6s plus 8 into 2s whole divided by s power 4, which is equals to 0. So that s power 4 will be gone. So what you have left with, 2s cube plus 6s square minus 2s cube minus 12s square minus 16s, which is equals to 0. So this 2s cube and 2s cube I can cancel. What I am left with, minus 6s square minus 16s, which is equals to 0. So let me take 2s as common. Let me take minus 2s as common. What I will be getting is 3s plus 8 I am getting, which is equals to 0. So what is 1 point? S equals to 0 is 1 point. And minus 8 divided by 3, minus 8 divided by 3, which is equals to minus 2.66 is a valid one. Minus 2.66 will be over here. It is a valid breakpoint. And s equals to 0 means it is on the pole. It is also a valid breakpoint. So the valid breakpoints are 0 and minus 2.66. So the corresponding option that is going to follow is option 3 is correct. Convert 83FB to decimal number system. So 83FB is in hexadecimal format. So what you have to do is you have to convert into a decimal number. How you are going to convert means, what is the value of B? B equals to 11 into 16 power 0 plus F means it is 15 into 16 power 1 plus 3 means 3 into 16 square. 16 square is 256 plus 8 into 16 cube is 4096. On solving you will be getting 33,787. So this is how you are going to calculate from hexadecimal to decimal number system. The simple way is just convert into a binary. What you will be getting is 1000, 0011, 1111, 1011. Now what is this value? 1 into 2 power 0 you multiply. Next 1 into 2 power 1 you multiply. Next 1 into 2 power 3 you multiply, and so on. If you are adding, then also you will be getting the same number, that is 33,787. So the suitable option that is going to follow is option 2 is correct. Power spectral density of a white noise affects all the frequency components uniformly, because what is the power spectral density of a white noise? It is having a constant amplitude with amplitude value equals to n0 divided by 2. So white noise is the one which is going to affect all frequency components. A pink noise which is going to affect only a particular range of frequencies. So option 1 is correct. Always inverse root locus starts from 0 and ends at pole. Now if I am talking about root locus and inverse root locus, in the case of root locus always you will be going from pole to 0. But in the case of inverse root locus, 0 to pole you are going. And what is the angle of asymptotes? Angle of asymptotes which is equals to 2q plus 1 times of 180 whole divided by p minus z. Similarly, in the case of inverse root locus, it is 2q into 180 divided by p minus z. Say suppose if I am telling a point is on root locus, then it has to satisfy magnitude condition as well as angle condition. So the suitable option that is going to follow is option 2 is correct. The percentage saving in the case of DSBSC modulated signal at 80% modulation is. Now in the case of normal modulation, what you are going to do is you are going to send the carrier power as well as upper sideband as well as lower sideband you are going to send. But in the case of DSBSC, what you are going to do is you are going to suppress this carrier. You are going to send only the upper sideband as well as lower sideband you are going to send. Right? Now if I am talking about percentage saving, if I am talking about percentage saving, PC you are saving out of total power. Right? What is PC? It is PC. Right? What is PT? PT equals to PC into 1 plus mu square divided by 2. So what I will be getting is 2 divided by 2 plus mu square. Now what they have given is modulation index equals to 80%. Here I am assuming the default carrier is a sinusoidal. I am assuming it is sinusoidal. So what I am getting is 2 divided by 2 plus 0.8 square will be 0.64. So 2 divided by 2.64 will be 78.76 or 75.76, right? So rough value you can take it as 75.76 you will be getting, right? So which is close to 78.76. So the suitable option that's going to follow is option 3 is correct. Bannerghatta Biological National Park is in which state they are telling? It is in Karnataka. So the suitable option that's going to follow is option 2 is correct. So in this video we have discussed 30 questions. To attend the quiz questions daily, please join our Telegram group. Daily you can take the test at 10 o'clock so that you will be getting prepared for your exams also. So if you have followed this solution video, please give it a big thumbs up. Also share this video with your friends and don't forget to subscribe to my channel Craving Gyan. All the best for exams. Thank you.